Okay, let's talk about how you solve second-order linear differential equations with constant coefficients. They look like this, and the basic strategy in that case is to assume that the solution takes that form. Maybe you can see why we do that. We took earlier this example, and I just wanted everyone to look at this and think about what kind of function could do that. Such that you had the second derivative minus the first and you got 0. One thing that we came up with and verified was the exponential function. So alright, let's say that anytime we get something like that, let's just assume that the solution is going to take this form. Now, here's the differential equation that is on the other side of the paper, and I said we were going to assume that, and r is some constant not yet determined that, precisely found would make this be a solution to that. So let's go looking for the r. Alright, so there's y, we assume that much. Here's y prime, here's y double prime. And if that's the case, then our differential equation here would take the form r squared e to the rt minus r e to the rt, and that would be 0. And there's some value of this constant up there, r, that apparently is going to make this happen. All right. In order to figure that out, I notice this is a constant and non-zero factor in both terms. I can remove it. I get like so. And since that's, I guarantee you that's not 0, I can divide it out. And I get like so. And then this led me to two answers. R is equal to 0. The other one, R is equal to 1. Okay? Now, really quick, some jargon. When we take a problem like that, and we assume this solution, and then we substitute it accordingly, we get something called the characteristic equation. All right? We do that. We get the characteristic equation, and we find its solutions. And those are what ultimately gives us the general solution to this. Now, I guess what that would tell me is that one solution is some arbitrary constant times e to the 0 times t power. And what is that? E to the 0 power would be 1, so that's just an arbitrary constant. So a constant function would be a solution to that. What's another one? Say we found that r is 1. What's that mean? r2t, second solution, could be some other arbitrary constant, times e to the t. Okay. Where that, I'd leave it like that, and that's all I'll tell you about it. Now, say I found that this and this work. Both of those, I promise you, will work here. What we talked about in another video, the principle of superposition, that if you take a second-order linear differential equation, if you find two solutions, any linear combination of them is also a solution. So that gives us a way of finding these on their own that we could give the general. So to that thing, I give you this general solution. It's going to be y is a function of t, and I'll say c1, a constant, plus c2e to the rt. So there it is. Anything that would be a solution to this takes that form with whatever the constant c1 and c2 would have to be. Well, that's the same thing that we concluded over here, basically.